So number 2 then from the 2022 Advanced Higher Mechanics paper, 3 marks for partial fractions. Express this function as a sum of partial fractions for those 3 marks. Well, a little bit of respite when you just get a purely mathematical questions because it's just technique. Well, all you want to do is make a partial fraction for each of the linear factors in the denominator. So I'll have something over the 1 plus x. Now the 1 minus x is down there twice. So you can't put plus b over 1 minus x plus c over 1 minus x because that'd only be one term, common denominator. And those wouldn't combine to produce this. What you do is you put c over not just the 1 minus x, but the 1 minus x squared. Now, where that actually comes from is to say, well, if you just treated that like an irreducible quadratic, but it's not obviously, then that could be written as bx plus c over this. And you could go through it and find the a, the b and the c, but then you could expand that by manipulating the top and it would break apart into this, except that number c wouldn't be exactly the same. But anyway, so you do this, that's the first mark. Now you've got to compare the two because these are meant to be exactly the same. So if you were to add them back into a single fraction, what would the new numerator be? Because whatever that is, it should equal this. Well, a would need to get multiplied by, it would need one of those to make the common denominator. Sometimes you just think, take that across and multiply. So that knocks out that. But what you're really doing is making a single fraction. So a will need this, or you can think of that. B will need one of each of those. C just needs that. That would be the new numerator up here, and that should equal this. Now normally that would be the next mark, but there's only 3 marks altogether, so what they're saying in the marking scheme is, right, doing that and getting the first of the answers. Now there's 2 techniques for the answers. Since this expression should equal that expression, you could extract the x squared terms and compare them to this, or the x terms and compare them to that, or the constant terms and to compare them to that. Or you could just use knockout values. So I'll do that to begin with. If I use x equals -1, that'd be quite handy because that'll knock out that and give me a straight away. So if x equals -1, that means that I've got -1. 1 take away -1 would be 2. 2 squared is 4. I'd have 4a. And put -1 into this gives me a 2. And a plus 3. -1 squared is 1, but minus a 1. So 4a equals 4, which means a equals 1. Now you get the first mark. That's meant to be equals -1 there. Now I could do x equals 1. That would knock out those. So that would knock out that, and just leave you this. So with x equals 1, you've got 2c. With x equals 1, you've got 2 minus 3. Still -1. So that's -2. Half that, divide by 2. So that means you've got -1. Now there's no more knockout values, so you have to resort to the sort of proper algebraic technique of comparing corresponding coefficients. So which one might be handy? Well, I want one with b in it, obviously, don't I? So what would b produce? B can either produce a constant or an x squared term. I'll say I go for the constant. If I go for the constant, then what's the constant term? I'd be better going for the x squared term. Yeah, I've done it now. Because with the x squared term, I've only got a making an x squared because c doesn't. But as with constants, a makes 1 and c makes 1. I've done it now, so I'll just do it. Maybe I'll rub it out afterwards. So the constant term, there'd be 1 there, there'd be 1 there, and there'd just be 1 of b. So all of them would add up to make 2. Well, that just means that the b will be 2. Well, those 2 add to 0. Well, that was quite handy, actually. So that comes to 2. So that's the remaining 2. If I had gone for the x squared terms, what would have happened then? Well, that's a plus x squared when it multiplies out. So there's a lots of x squared there. That's a minus x squared when you multiply it out. And that comes to a -1. Maybe that's a bit messier. So taking the b across and taking the 1 across and adding it onto a would give you b equals 2. But anyway, now you just put it all together. So what does it all equal then? Well, it was 1 over 1 plus x plus 2 over 1 minus x, but minus 1, just put the minus to the front, over the 1 minus x squared. The marks have all gone. Because it does say express it as a sum of partial fractions, but the third mark was for getting the remaining two unknowns, so they'll have to pop into and then expressing it as a sum of partial fractions.